Hi, this is Charity, and this lesson is going to teach you about linear regression. It's section 1.3 in the Finite math textbook. So what we're going to talk about is we've been looking a little bit at linear lines, being able to take data and that forms a line and calculating the equation of that line. So give me a sec. I'm going to go ahead and share my screen here. And we're going to pop over so you can see me and you can see my paper here. Okay, so this section again is 1.3, and the reason, or what I passed out in class, or what you can get available online, is this little worksheet here that kind of goes over real world problems, and we're constructing a model. So basically the idea is using the past or some data that you have to predict something in the future. So we want to come up with an equation so we can interpret and predict that future. So this goes through construct your model. That's going to be to draw the scatter plot. That's the connection between the two ideas. And then solve the mathematical model. That depends. And then interpret your solution. Okay, and then it kind of goes through how to do it on the graphing calculator here. I will show you that. So let's look at this problem here, this first problem here. It's not quite going to be one that we're going to do on the technology yet, but let's walk through this. So we have depreciation. A new car is worth $45,000 and is depreciating at $5,000 per year. Find the linear model that for the current value of the car, V, and the number of years Y after it's purchased. Okay, so we have to think of the slope. The slope is your rate. What are you doing? Well, you're depreciating. So that's going to be negative, and it's going to be $5,000 a year. So you're going down $5,000 a year. So that's going to be our slope. Okay, so for A, my thing was in the way. We're going to think of this as the number of years after we purchase it. The linear model for the current value of the car is V. So the current value of the car is going to be equal to a negative 5,000 times however many years have gone by. My V kind of looks like a check mark. And then you have to add to it your starting amount. So you should be able to look at these problems and think of slope as what your rate is, going down or up, depends, and your starting amount. Okay, that's it. That's for A. So that's our equation of our line. What if we wanted to interpret what the slope represents? So this slope represents that we're decreasing by $5,000 per year after it was purchased. So that's what that slope represents. So I'll write that for you. The car's value decreases by 5,000. That decreases is going to assume that negative by 5,000 per year. And if this would have been like 5,000 over 3, it would have been 5,000 per 3 years. So if we would have had a fraction, it would be the second number would be in front of here. So after the word per is always your denominator, and ours is a 1, so it's per year. So we're decreasing 5,000 per year after it was purchased. Okay, and then the next question says, if the car is 3 years old, what do you predict? What does this model predict for us for the value? So for that one, we got to think of, and this one said 3 years old. Find the value. Okay, so for this one, we're going to be like using our formula here, and we know that the value is equal to the negative 5,000 times the 3 plus the 45,000. So I'm going to be sneaky and get out my calculator here. And I'm going to plug in the negative 5,000 times 3 plus 45,000. And I'll get 30,000. So the value of my car now is 30,000. So I came up with a linear model. I answered some questions about the slope. Remember, the y-intercept's like your starting amount, and that slope is going to be your rate. And then you could use your formula if needed. Let's figure out also how many years till this car is worth nothing. Okay? So after how many years is the car worth nothing? So we got to think of the value we want to be 0. And it's got to equal our 5,000 times our years plus the 45,000. So we'll just solve this equation. We're going to subtract over the 45,000. Subtract over the 45,000. So I'll have negative 45,000 over here equals negative 5,000 y. Okay, and that part went to 0. Then I'm going to divide by the negative 5,000 to solve for my y. And let's see what we get here. Negative 45,000 divided by 5,000. Negative is going to be positive 9. So 9 years and our car is basically worth nothing, right? So that's how you can kind of look at that problem. Let's flip over to this next one here. Actually, we're going to flip to number 3. So you can do number 2 if you want. It's very similar to the one we just did. So we're going to flip over to number 3. And this one is a little different. This one's about stress, and it says, the table below shows the relationship between a stress test score of a now I can't even say that word, blood pressure for 8 patients. A linear regression model for the data is given. So they gave us the model, and then here's the data. Interpret the slope of the model, and then use the model to predict, and then we're going to use the model to predict. So what I'm actually going to do is I'm going to do, I like the questions that they gave, that's great, but I want us to be able to come up with that equation from data. So, and I thought the next one, nope, that's all they gave. So this is another part that's important. So that's the one I'm going to show on technology. So we're going to stop. We're going to answer these questions in just a second, but I want to show you. So if I want to find this equation from data, sometimes in my math lab, there's this little square bucket. Like it looks like a tiny little square like that with like a square inside. You can click and copy the data and move it into Excel really easy, which is amazing. But for this one, we're going to do it on the calculator. So what we do on the calculator is we hit stat. Let me scroll that up just a tiny bit. We hit stat. And then in this edit, so we hit stat and then enter right away, we're going to have these lists. I'm going to go up to the top of list 1. See, I'm highlighted on L1. I'm going to push clear and enter and do the same thing on L2. You can't push delete. You got to be careful in there. That way, the list 1 and list 2 are free. And I'm going to do my X values in L1 and my Y values in L2. So let's put in our data. We have 55, 62, 58, 78, 92, 88, 75, and 80. Then for list 2, I'm going to have 70, and they should line up, right? Because they were a data together here, a data point. So 70, 85, 72. I was just double checking a couple of mine as I go through. 85, 96, 90. Make sure they're all lining up. 82 and 85, and they did. They all lined up. So you can't have like one line longer than the other. They're a relationship between two things. So each L1 and L2 are connected. Okay. So then from here, I'm going to hit stat, and if I hit enter again, I'll get right back to those lists. I want to go over to this calculate button, and I want to go to linear regression. Okay, I'm going to hit enter, and I'm going to hit enter again. If your calculator is a little newer, it'll say list 1, list 2, and you just got to make sure it's on list 1 and list 2 for what you're doing. So here's our equation. Our A value is 0.56. Look, it's the same A value. They just rounded. And our B value, well, X, you call them M and B, but they call it A on here. Anyway, so you can see the 41. They also give us these R's. That's our correlation coefficient and our, well, basically, if your R is a 0.9, the closer it is to 1, the better this relationship is. So it is like thinking of it as a 90% accurate. It's a very good model or representation of the blood pressure versus that stress test. So that means it's good. If this value was like a 0.5, not so good. Okay, so we're looking at that. Okay, so the other way we can do that, now bounce into Excel real quick. So the other way will be in Excel. And again, we have to put in our data. So think of like row 1, row 2, our X and Y's. And you can do this in Google Docs too. It's just a slight bit different, but you can still do it in Google Docs. But we had 55, 62, 58, 78, 92, 88, 75, and 80. And then our second one went 70, 85, 72, 85, 96, 90, 82, and 85. Okay, they lined up. So I put my data in, and then I can highlight it, and I'm going to go to Insert, and I want to insert a scatter plot. Okay? So I insert my scatter plot. Here's where it's a little tricky. If you have the newer version, you can see this plus that comes up. So I'm going to do plus, and I want a trend line. So I click trend line, but to get to like the options, I have to click here. Let me show you again. I'm just highlighting over it. So my mouse is just sitting there, and I go over and I click on the arrow, and I can say linear, and I can also go down and do more options. So that clicks up my options over here. So everything we're doing today is linear. And down here, I want to display the equation on the chart. Otherwise, I can't see it. Sure, it made the equation, but it doesn't do us any good if we don't show it. So there you go. So now I can see that equation. Again, I went to plus, trend lined, and I went over here to this little arrow, and I clicked more options, and I did linear, and I went all the way down here, and I said, display the equation on the chart. It displayed it twice. And we can get our R squared. R squared's a little different than R. We'll go over that later in the semester. You might have already learned about it. All right, so there you go. All right. So Excel is important because in business, you might have to create some kind of sheet or document that specifically goes with your job. So being able to use Excel is an amazing skill for a business. Okay, so let's go back over here. So now we've learned how to write this equation if it wasn't given to us. Now let's interpret this slope here. So if we interpret the slope, it's 0.56. So think of that as the blood pressure over our stress test. So we're going to think of it as Y over X, our blood pressure, which was 0.56 over 1. And I'm going to think of it like this. It's blood pressure per whatever's on the denominator, which was our stress test score. So there's a way to kind of help you with how to think about the slope. The slope is always our change in Y over our change in X. So change in Y over change in X. Blood pressure per stress test. Okay? So use the model to predict the blood pressure for a person. So this was A, B. So use the model to predict it for a person who with a stress test score of 75. So we have to think which one was our score. Our score was X. So I'm going to put that value in for X, 0.56 times our 75 plus our 41.71. And again, we'll just calculate that out. So we have our 0.56. We're going to times that by 75 plus 41.71. And I got that Y equals 83.71. So that means our blood pressure is around 83 when our stress test was 75. Okay. All right, so the next one's just an equation too. I think I'll go ahead and skip that. So if I went fast, rewind the video, watch how I did it on Excel, and try it again. So that'll help you with your homework. If for some reason you put in 0.56 and they tell you the answer is 0.57, sometimes there's a little bit of rounding errors. So just shoot me the Ask the Instructor button if you need me to add a point in because you have the right answer, but it's a little off. Okay, if I made sense with that. But anyway, so for the most part, this section should be review. Oh, I know what else I wanted to say before I leave. Another thing you could do is to do this by hand. Not as accurate, and your answers won't match. But you could make a scatter plot and draw your line of best fit. And then from your line of best fit, so like for this one, I'm not going to draw it exactly. These were my dots. I'm going to draw the line that goes through my dots the best it can. And I find any 2 points on that line, and I can find my slope and use my point slope form and find the equation of the line. Like, you don't have to do this on technology, but technology uses least squares method, which means it makes that line as perfect between your dots as it can be. So definitely better on technology. All right, I will see you all on Monday, and I'll be happy to answer questions then.